Hello, my name is Maufido. So today I will talk about the introduction of the project. The traffic congestion and safety concern arise at the signalized intersection due to the increased population, economic growth, and the vehicle ownerships, leading to the worst urban mobility and environmental impact. The second one is intersections efficiency depends on the geometric design, signal timing, and the traffic composition with the geometric improvement offering long-term benefits while signal optimization enhance real traffic flow.
Hello, my name is Jazila binti Jamian. My metric number CF220191. I continue our group presentation about methodology. First, at the UTHM signalized intersection, conduct traffic movement count on all approach for 1 hour in 4 segments of 15 minutes. Record the data in table provide. Third, measure the lane width W in meter for all approach and record the data in table provided for data analysis. Next, for each space, measure the green time and circle time, record the data in table 2.1. Next, convert traffic volume recorded in all of the table for passenger car unit. This is taken as the design flow Q, which will that be used in table 2.2. Next, determine the adjust saturation flow S for each approach and transfer the volume to table 2.2. Next, using table 2.2, compute Y, which is the ratio of design flow to adjust saturation flow, and determine the Y volume, which is the total volume of Y for each approach. Next, then calculate the intergreen time I and total lost time per circle L. Determine the practical capacity Y practical and reserve capacity RC of the intersection. Determine the average stop, delay per vehicle D, and level of survey for each approach.
Hello, my name is Nufatra Ainur binti Muhammad Anwar, metric number AF210125. So in this project report, I will talk about the data presentation. For the signalized intersection capacity study at Parit Raja, data was collected on Thursday, 25 April 2025 between 4:30 p.m. and 5:30 p.m. for lane 1 under sunny weather conditions. The traffic count was categorized into 4 vehicle classes, which is motorcycles, cars, vans, and medium trucks, and heavy trucks or buses. From Parit Raja to Batu Pahat, over the 1 hour period, a total of 85 vehicles were recorded, with cars making up the largest portion at 56 vehicles, followed by 24 motorcycles, 4 heavy vehicles, and 1 medium-sized truck. The highest traffic flow occurred in the last 15-minute interval from 5:50 to 5:30 p.m., where 27 vehicles were observed. To standardize traffic volumes for analysis, passenger car units were applied. The total passenger car unit per hour was calculated to be 74.67, with cars contributing the most at 56 passenger car unit per hour, motorcycle at 7.92, heavy vehicles at 9, and medium trucks at 1.75. Based on standard lane capacity of 1,800 PCU per hour, the volume to capacity ratio was approximately 0.042, indicating a very low traffic load. Next, for the left turn movement at the signalized intersection from UTHM to Parit Raja, a total of 252 vehicles were observed within the 1 hour period. Cars formed the majority of traffic with 158 vehicles, followed by 77 motorcycles, 8 medium trucks or vans, and 9 heavy vehicles. The total flow was calculated to be 217.66 passenger car unit per hour. Cars again dominated the PCU value at 158, while motorcycles contribute 25.41, heavy vehicles 20.25, and medium trucks 14. This indicates that the intersection is still operating well below capacity with minimal delays. Then we also collect data which is from Batu Pahat to Parit Raja through from Batu Pahat to UTHM, which is left turn, the data of U-turn from Batu Pahat, the data of U-turn from Parit Raja, and also from UTHM to Batu Pahat, which is right turn, that we include in our project report.
My name is Muhammad Alif Haikami Faisal. My matric number is CF220043. I will present about the analysis for this study, which is the signalized intersection form analysis. We make the analysis based on the data that we gather on site, which is in front of the main gate UTHM. First I find the GC, then the G I divide by C, and then I find the saturation flow rate using the PCU data, and then after that I multiple the flow rate, which is Q, which is S, per PCU, which is Q, and then for the data I find the delay. After that I determine the LOS based on the table using the delay data. From this table we can see that the LOS we get for the Parit Raja through is B, Parit Raja turn right is E, and Parit Raja U-turn is B. And then for the phase 2 from Batu Pahat through 2 is D, and Batu Pahat through 3 is C. And then for the phase 3 is Batu Pahat left, we get the A, Batu Pahat U-turn, we get the B. And then lastly the phase 4 from UTHM turn right, we get the B, and UTHM turn left, we get the B. Okay. My name is Muhammad Alif Haikami Faisal. My matric number is CF220043. I will present about the analysis for this study, which is the signalized intersection form analysis. We make the analysis based on the data that we gather on site, which is in front of the main gate UTHM. First I find the GC, then the G I divide by C, and then I find the saturation flow rate using the PCU data, and then after that I multiple the flow rate, which is Q, which is S, per PCU, which is Q. And then for the data I find the delay. After that I determine the LOS based on the table using the delay data. From this table we can see that the LOS we get for the Parit Raja through is B, Parit Raja turn right is E, and Parit Raja U-turn is B. And then for the phase 2 from Batu Pahat through 2 is D, and Batu Pahat through 3 is C. And then for the phase 3 is Batu Pahat left, we get the A, Batu Pahat U-turn, we get the B. And then lastly the phase 4 from UTHM turn right, we get the B, and UTHM turn left, we get the B. Okay.
Assalamualaikum and hi, my name is Siti Fazal binti Muhammad Latif, matric number AF210123. So the continuation from previous slide, my part is analyze intersection performance analysis. So we find G and C and then divide them, and then we find the S prime, the Q, the Q1, then Q divided by S prime, and then we find the D, and then we get the LOS for the lane. And then lastly, for the calculation, we find the lane group capacity analysis, we find the movement, and then W, and then S prime, and then Q. Lastly, we get the Y for 4 of the lane.
So this is the discussion of the project. The first one is uneven traffic flow cause delay. The certain movement like PR2 and BT2 face height delays with a loss E and D, while other operate efficiently loss A and B, showing the imbalance in the signal timing relative to the traffic volume. And the second one is the efficient and inefficient lanes. Some lane like BL4 and PT1 perform efficiently with minimal delays with loss A and B, suggesting an imbalance in signal timing allocations across the phase and the approach. The third one is the signal timing, the main issues. The intersection geometry is adequate 3.5 meter lane. So the main factor affecting performance is poorly allocated green time across phase, not physically constraints. And the last one is improving the timing and can boost efficiency. The adjusting green times based on the traffic demand can significantly reduce delays and the congestions, enhance overall intersection performance without major infrastructure change.
Hi, my name is Muhammad Firza Aidi bin Muhammad Hamadi. My metric number is CF220123. So my part is conclusion. For this our project, we conclude that signalized intersections are vital in urban transportation but face increasing congestion due to population growth, economic development and rising vehicle ownership. This conjunction negatively impact mobility and environment sustainable. Intersection efficiency is influenced by signals, timing, geometric design, and traffic composition, while traffic conditions fluctuate. Geometric characteristics are fixed and can be exchanged, enhanced to improve long-term traffic flow. Signal timing optimization play a crucial role in managing traffic flow. Proper time allocation among conflicting movement reduce delay and conducive improving intersection operation. Okay, thank you.